if it's a little more boring? Because there's a chance that we were hit by an interstellar alien artifact back in 2014, but it landed in the ocean and no one was around to see it. Also, the definition of alien is still up for debate, and that is where Harvard astrophysicist Avi Loeb comes into the picture. He's the guy who wrote the book about alien stuff flying in space. Literally, it's called Extraterrestrial, the first sign of intelligent life beyond Earth. And he wrote it after studying that other weird asteroidish thing called Oumuamua that we detected flying through the solar system, saying it might have been an alien probe from a different galaxy. You remember those headlines. Well, after that, he went back and he started looking for records of anything else that might have come from a different galaxy and found that something crashed into the Pacific more than 10 years ago. Then he did a bunch of math that is way beyond my head, and the next thing we knew, he was leading an expedition off the coast of Papua New Guinea on a ship dragging this magnetic sled, looking for pieces of what they now call 1M1 on the bottom of the ocean. And guess what? He found something. And now we are starting to see the first close-up images and scans of what researchers think are fragments from that crash site. Now, Professor Loeb is just back from that expedition, and he's now back to work as head of Harvard's Galileo project, which is looking to answer the biggest question on Earth. Are we alone in the universe? Professor, thank you so very much for joining us. I see you're back in this suit, but we saw you on the deck of that ship. Spoiler alert, before we hype you up too much, I've seen no evidence that you came back with an intact craft. But that's how science is supposed to work, right? What did you find on the seafloor?
Well, it's quite remarkable. There was a fireball back in 2014, and the outer surface of the object obviously melted because the amount of energy released was a few percent of the Hiroshima atomic bomb energy, and you expect any material to melt under these circumstances. And the droplets of melted material fell to the ocean floor, and they laid there for almost a decade, until we went there with a ship that was fittingly called Silver Star. And we used a magnetic sled, basically a sled that is covered with magnets on both sides. We kept it on the ocean floor and went a distance of 10 kilometers for each line of our search. We crisscrossed the region that was defined as the meteor site by the Department of Defense. And amazingly enough, I mean, we had an estimate for what the path of the meteor should have been, and we found small droplets of, basically they look like metallic marbles embedded within the volcanic ash that was everywhere. And we found them primarily along the expected meteor path. So there is clear evidence that they are related to this meteor, and moreover, we have them in our hands. It's the first time that humans hold material belonging to a big object that came from outside the solar system.
A lot of people are going to see this and they're going to say, oh, actually, you know, asteroids and meteors have been hitting Earth for quite some time. What makes this different?
Well, the asteroids and meteors that we have seen before were all bound to the sun gravitationally. So they were orbiting the sun. They were debris of the material that made the planets in the solar system. However, this object was moving faster than the escape speed from the solar system. It was moving at 60 kilometers per second relative to the sun outside the solar system. And that's faster than 95% of all stars in the vicinity of the sun. Moreover, this object maintained its integrity down to the lower atmosphere above the ocean surface, about 20 kilometers there. And that implied that it was made of materials stronger than all the meteors on record, 272 of them in the NASA catalog. So this material was tougher than iron meteorites. And it raises the possibility that because the object was moving fast, perhaps it was assisted by some artificial propulsion, and perhaps it was made of some artificial alloy, the way we make our spacecraft. Because if you imagine Voyager, Pioneer, New Horizons that were launched out of the solar system, in 1 billion years from now, they will not be functional and they could collide with an exoplanet, creating the appearance of a meteor on that planet. And a scientist over there that is curious enough could find the debris. Yes, we did.
Okay, so now everyone's attention is peaked. You said artificial when you're talking about interstellar. If this thing wasn't being pulled in by the gravity necessarily of the sun and it came from outside of the solar system, what do you think it could be?
Well, the point is, it's not a matter of opinion. We don't need to assume anything. We have the material in our possession. That's the beauty of it.
We don't need to assume anything. We just need to get a sled and put it on the bottom of the seafloor and do science.
Well, it was a very challenging task because the depth of the ocean is 2 kilometers. We had a sled of 1 meter in width, and we went along lines that stretch 10 kilometers in length. And the fact that we were able to find these millimeter scale droplets, metallic marbles, spherules, is remarkable. It's a remarkable achievement. There was a team of exceptional professionals that contributed to that success. I was doubtful that we will find anything, but we took the risk and we found it. And now the next task is to examine the materials. And we have state-of-the-art instruments at Harvard University that we will use to study the material that made this object and look for things that do not resemble what we find in meteors, rocks in the solar system. For example, imagine it was an artificial object and there were semiconductors that were melted. Obviously, we will find trace elements that are not common to rocks. Also, these spherules that are millimeter in size, you can think of them as romantic rose petals that lead us to our partner, so to speak. And the partner that I refer to is any big relic that was left behind and is lying on the ocean floor. We now know the path that the meteor took, and we can plan for the next expedition where we will go after any big relic and using completely different machinery that will image the ocean floor. And if we find it, we could tell easily the difference between a rock and some technological gadget. And we might even, if it's a gadget, we might even see a label made on exoplanet Y, and it might have some buttons on it. So in the last class of my spring semester, I asked the students at Harvard University, I said, if we find a gadget and it has buttons on it, should we press a button? And half of the class said, no way, that's very risky. You don't know what will happen if you press a button. The other half said, that would be amazing. Let's see what happens. Maybe it's GPT 100. And then one of the students asked me what I would do. And I said, well, I will bring it to a laboratory and first examine it before engaging with it.
Well, when you do, please invite us. Also, I can't wait to see when these results come back. Just real quick, what's the timeline, do you think, for when you could see some of those results?
Yeah, so within the coming weeks, it's just a matter of weeks for us to run the spherules through, X-ray fluorescence devices, electron microscopes, all kinds of instruments that allow us to get a peek as to what the spherules are made of and what their structure is. Already what we see from a very preliminary analysis is that each spherule has spheres within spheres, just like Russian dolls. And it's really interesting because it means that tiny spheres on the scale of hundreds of atoms condensed first, they solidified, and then bigger droplets of liquid engulfed them and then solidified. So you end up with spheres within spheres. That's an amazing view, and we just got it from an electron microscope. And we also have some preliminary analysis of the composition, but we want to get a large enough statistical sample of the spherules we have at our possession. We have more than 50 of them, and we will find more in the materials that we collected. But the basic point is, we are following the evidence, and whatever it shows us, we will report to the public in an open way. And one thing we already know is that the spherules that were found along the preferred path of the meteor. They were mostly there. They were not in control regions, in distant locations that are far away from this path. And that shows a link.
Professor, thank you so much for joining us. You set off to find a needle in the biggest haystack I can imagine, and you came back with 50 of them. Can't wait to see those results. Professor Loeb, thanks so much for joining us.
Thanks for having me.
Thanks for watching our YouTube channel. Follow today's top stories and breaking news by downloading the NBC News app.